If you didn't get a chance to attend the last event, no worries. We will try to. I will try to explain everything clearly. So, yeah, but also you can visit our YouTube channel just to check the previous session, the previous event. So here are all the links to our social medias. So I pasted them in the chat. So just briefly, we'll go through them. Gtac Portal is where you can find all of the events. You can just join our chapter, Conestoga College Waterloo campus, and there you'll be able to track all of the events. Then I will duplicate since other people joined as well, so they can see the links as well. So then we have YouTube channel. We will so we do recordings of these sessions, and you will be able to find them on our YouTube. You also can see like intro to Git and GitHub that we had last week there. We have our LinkedIn group, Instagram, Facebook, Twitter. So whatever you're comfortable with, you're welcome to follow us. And yeah, that's great. So again, I will probably then start recording. Andre, I would like to ask you to do the same thing as well. So we have 2 copies just in case. It's already been recorded. Cool. 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 Welcome everyone again to Git and GitHub part 2. Before we start, we'll just introduce ourselves. My name is Alexander. I am Google Developer Student Club Lead at Conestoga College. Yeah, I will pass it to Andrew. I'm maybe actually no. Before I do that, I will give you a bit of overview of myself. I'm a CPA student, a computer programmer analyst student. I'm currently on my 3rd year completing my co-op at a company called Vehicle. You can check them out here. And that's essentially about me, just briefly. So Andrew, sorry.
Yeah, hi everyone. My name is Andrew. I'm the GDSC Vice Lead. I'll be helping out Alexander throughout the session. In the comments, if you have any questions throughout the session, please feel free to leave a comment. I'll try to answer that and bring a question to the Q&A that we'll have at the end of the session. Yeah, I hope you learned something today.
Yeah, sorry, that was typo. So, cool. Then agenda for today. So this, okay, let me just, I have too many icons in here, so just minimize them. Okay, cool. Now I can see the screen. So you can see my presentation, right? Never, okay. I assume that's good. Cool. So yeah, our agenda. So we had our intros. We will. So essentially, yeah, this workshop. So the purpose of it is to give you like the grasp of concepts that you need to learn. And I will give you like a small introduction to each of these that you can see here. So I just like a disclaimer, like don't be overwhelmed by the end of the session if like if it seems a little bit complicated. I will do my best to explain it, but still, like, you will master these concepts as you go. So yeah, just here again, the purpose of this workshop is just to give you a general overview, make you kind of feel comfortable using these terms. So like if somebody, so I hope that by the end of this workshop, you will be able to like understand if somebody says, I will do rebase, or I will cherry pick a couple of commits, or I will squash some commits. So this is like the goal of the session, right? So I will, we have slides, and also we'll do demos. So I will try to make it as accessible as possible. So yeah, that's essentially about it. Our topics, we will cover Git Ignore file, what it is, then merge versus rebase, cherry picking, squashing, fork versus clone. Actually, could you please, like maybe I would appreciate if you could drop a message in the chat saying how, like, do you have a basic understanding of Git? Like maybe, how comfortable are you with Git? Like, are you completely new? Do you have like some basics? Like, do you know what commit is? Do you know what, I don't know, branch is, something like this? Cool, basic knowledge, code on assignments, new. So basic, cool. 5 out of 10, cool. Okay, cool. I'm completing you outside of, okay, cool. Yeah, if you attended last week's session, that's totally enough. So yeah, if you weren't able to, again, I do suggest you check it out after this one. But again, no worries if you didn't, so it's totally fine. So let's probably start. So the first thing, so I will assume a couple of things that I covered during the last session, but I will also recap some of them. So last session, we talked about local and remote repositories, right? So we defined what a repository is, what working directory, staging area, and repository are. So essentially, like, working directory is where your project is located. Repository, it's like where you do all your commits. So again, and to remind you, commits are like snapshots of your code. So like you have different versions of your code, right? So every time you do commit, Git does a snapshot of your code. So, and it kind of tracks the versions, right? And staging area is essentially for preparing your project for a commit, right? So essentially you just add files that you want to commit in staging area. And then if you are satisfied with your staging, you can commit to a repository. And then we also discussed like about remote. So remote repos can be created with GitHub, right? And to push your local repository, so your local project to your remote GitHub repository, you just need to do git push. And if you want to get the most recent changes from remote repository, just do git pull, right? So this is like a small recap of what we learned last session. And so the first thing I would like to talk about is Git Ignore. So what Git Ignore is, it's essentially it's a file, right? A file that starts with the dot. If a file starts with the dot, it means that it's a hidden file. So you would not be able to see it usually unless you check one option to be able to do so. So essentially, and this file, its purpose is to hide some secrets, right? So let me probably switch to, sorry, I'll go here. And I will probably do demo right away, so it makes some sense what I'm talking about. So if I just close this stuff, cool. So I will just go to a folder that I created. Again, you can follow me if you would like to, but again, no pressure. You can rewatch it later because we record it. We will post it on YouTube. Yeah, just try to understand like the concept itself. Okay, this is like the most important, and then after this session, you'll be able to practice like on your own. And also, I want to emphasize practice is very important. So as you go during your studies, you will polish these concepts, so they will become you will be more comfortable using them. So yeah, again, here we just learn the basics, the concepts themselves. So just try to understand what I'm talking about. So imagine this is your project. So I will just create a new folder called project, right? And I will open Git Bash here, window here. Okay, let me maximize it a little bit. So yeah, that's it. So this is my project, and this is my Git Bash console. So here, and I'm currently, as you can see, I'm in my project directory, so I'm inside this folder. So to start, I will just initialize git init. So again, it's kind of a recap of what we did last time. So git init, and it creates a Git repository, right? Local one. So you can see hidden folder. So I told you that if a file or folder starts with dot, it means it's hidden. So I can see it only because I enabled it. So if I uncheck this hidden items, I will not be able to see it, right? But I'm able to because I have this enabled. Also, so the next step would be, let's probably create like a basic page. So to create a file, you just use touch command. So index.html. And now you can see it was created. And also I want to open, I want to open this project in my Visual Studio. Oh no, it's going nuts. Sorry. Okay. So yeah. Now I have this project opened here. So now imagine, so let's do our commit. So again, recap of previous session, how to do commits. Just imagine I did something. So like some stuff here, some code here. Again, right now, the contents of the file do not matter. We just talk about file management, right? So this is like the most important focus that, yeah, the content of the files again doesn't matter. So now before we do any commit, we need to add a file to a staging area. So to add something to a staging area, we use git add command and then dot to add all files. And now we can do git status. Maybe I actually need to zoom in a little bit so you can see. Cool. And what git status tells us, so changes to be committed. So it essentially means that this file is in the staging area. So, and we can do a commit by using git commit -m and then here a message associated with that commit. And we just will say create a project or, okay, new project. That's it. So then I can view our commits using git log. So here I can see the history of my commits. So I can see my name, my email, the date when this commit was created, and the message, right? So now I can use clear command to clear the console. So that's about it. This is just a recap of what we did last time. Now it's the time to talk about Git Ignore, right? The file, essentially what I started with. To create a file, let's start maybe. We will create a file called secret file.txt. So now you can see it was created. I can see it here. So, and imagine, so this file contains like different passwords, API keys, right? So essentially like what I know this term may be unfamiliar to you, what an API key is, but essentially just think about it like when you create a big project, sometimes you just need to use third-party resources, right? And to access these third-party resources, you need to use API keys. So essentially it's like a way for your project to log in into a third-party service. That's essentially it. And you don't want to expose these API keys. You don't want to expose your passwords, your sensitive data for your project, right? And you want to hide it from other people. So you don't want to add it. You don't want to commit it at all, right? Because it's sensitive. If someone accesses this data, they will be able to use it, right? And you probably don't want it. So let's imagine here I have like passwords and some, okay, and secret data. That's essentially it. And then if I do, okay, and I don't want to commit it, right? So if I do git add, and then it will be in a staging area. And then if I do git commit -m and then message, it will commit this file. And again, I don't want to do this because it's sensitive data. I don't want to commit it, right? So to avoid committing this file, what I should do is just like to create a Git Ignore file. So this is what Git Ignore is for, to hide secret files from others. So Git Ignore. So I created this file. Again, it's hidden because it starts with the dot. I open it here. And then essentially, how do I hide this file? I just write its name, secret file txt in Git Ignore. So I just write secret file.txt. That's it. And again, it's very important that you save all your files. I have autosave enabled, so that's why I don't emphasize that I save all the files because they automatically are saved, but it's very important. Your commits will not be, you will not be able to decommit unless you save a file, right? So to do this, so now let's see what this Git Ignore did. If we do git add, you see that nothing was added to my staging, right? So, sorry, get the status. Yeah, you can see that only Git Ignore is in my staging, right? So although I added all of the files to my staging, because dot, it means add all files to staging, only Git Ignore was added. Why? Because secret file txt is already is specified here. So for instance, now let's do some changes here. And if I do again git add, and then I do git status, you can see that index was added, but no secret file, right? So what this is what Git Ignore is for. It just lets you hide files from others. So, and then if I do git commit -m add Git Ignore, cool. And essentially, so you see that only 2 files changed. So this file was not committed, so you are safe. Also another thing, so you can also hide folders. So like you can see, you can do secret folder. So then you just can specify a secret folder. So again, this folder will not be committed, right? And also you can do like wildcards. So like you can hide all of the text files, right? So to do this, it means just any name with txt extension should be hidden, right? So you shouldn't commit it. So that's essentially about Git Ignore. Can you give me a brief feedback if this concept was clear or I need to clarify something? Like, do you have any questions about this? Cool. Weird. Cool. Perfect. Thank you for your feedback. Appreciate it. So that's essentially about Git Ignore. So important thing, yeah, because you don't want to expose sensitive data, right? That's essentially about it. So the second thing I would like to talk about is merge versus rebase. So let me actually enable animation. So last time, again, we will do recap. We talked about branches, right? So usually like, so what a branch is, it's like a line of commits, right? A flow of commits, essentially. By default, the main branch is master in local repositories, at least in my case. In GitHub, you will see that the main is actually called main, but anyways, it doesn't matter. So we will assume that our main branch is called master, and essentially all the commits are done in this branch. So if I go to this git bash, you can see that here I actually can see my branch. So I'm on master. So this is like where all of my commits went. So here I'm on master. So imagine this scenario. We'll replicate it, but still. So just let's pay attention to the slides for now. So okay. In our master, we do one commit called M1, okay? Then we do another commit M2, and then we create another branch. So again, and branches are created to like work on different features, right? So imagine like you just initialize the project, you add a main page, and now you want to work on a separate feature. You want to create like a login page. So this is like an example where you can, when you would like to create a separate branch. So you create a new branch called feature, and then we do commit with message F1. And then imagine we just go here. So we do another commit F2. And yeah, and then we go back to master and we do another commit on master with M3. So this is essentially like the structure of our branch, of our branches of our project right now in Git. Now the question is, how do I bring, so imagine I finished working on this feature, and now I want to bring all the code that is in this feature branch into master, right? So to do this, I can use merge. So essentially what merge will do, it will merge two branches together. And essentially, if I do this command, so get merge feature from master. So if I, we will do demo, so no worries, I will explain it again. This is what we will end up with. So master will look like this. So we will have M1, M2, and then we merge these commits, right? So we have, since F1 and F2 were done after M2 commit and before M3, they are put in besides them, right? So, and then we have M3. And then when you do merge, it also Git creates a merge commit for you. So, and that's essentially it. So, and this commit is just created to like indicate that you merged the branch. So that's essentially about it, how merge works. Let's just do a quick demo. Where is it? So I will delete this project. Okay, maybe I will not be able to. Let me close it. Cool, I will close this one as well. And I will delete this project and create a new one. So let's do like project. I will call it project. Okay, this project is fine. Also, so I created a new file again, a new folder again, open git bash there, zoom in a little bit. And then, so here, what do we do? So again, I will try to replicate this same sequence. So I do M1 commit, M2, then I create another branch with F1, F2, and then I create, do another M3 commit. So we will just replicate this scenario, and then I will run this command to just show you in show you this in real life. Cool. So if I just close this, okay, just to check. Okay, nothing is there. It's great. So if I need to initialize repository, I need to, and right away you can see that I'm on my master branch, right? So branch is specified here in blue. If I do git, let's actually create a couple of files. So we'll, oh, sorry, touch index HTML. So, and also I will open this project in my Visual Studio Code. And now it's freaking out. So it's just a second. Cool. So that's here. Oh no. Okay. Sorry. Happens sometimes. So, and imagine, so I do my M1, right? So I save the file. Then to do a commit again, recap, just do git add, git commit, -m, and I call it m1, right? Then let's do another commit. So again, we replicate the scenario that we saw on the slides. So I do m2, and then I do git add, git commit 2. Now, if I do git log, you can see the history of my commits, right? So you can see m1 commit, m2 commit, and they are done both on master branch, right? And they are done by me and at that time. So that's essentially it. Now, according to the slides, we just create another branch. To create another branch, we just say get branch, and then I call it feature. And then I need to, so now currently, so to list all of the branches that I have, I just do get branch. So now we can see that I have 2 branches in my project, one called master and another called feature. Star indicates the current branch I'm on. So I'm currently on master. So, and you can see here to go to feature branch, I do get checkout, and then I do feature. And then now you can see I'm on my feature branch. And now we want to do what we want according to the slide scenario. We do feature HTML. And here I do my F1 commit. So I just do, what do? I do git add. I use my up and down arrow keys to switch through my command history just in case. So I do F1. Cool. Then let's do another F2. So I do the same thing. Add to staging area. Now commit. So now you can see git log. So you can see that I'm on my feature branch, and here you can see like history of everything, right? So if I expand it a little bit more, oh no, it's freaking out, sorry. If I clear it and do it again, so git log, you can see that I'm currently on feature branch. And you can see that up to this point, these commits are done in master. And then at this commit, I branched off and created a new branch called feature. And these commits are only in feature branch. So now, if I check out to master, now you see all changes are gone. Yeah, you cannot, this file is not here. We have only index. And if I do git log, I have only 2 commits, right? So in this, and let's do maybe a third one. So if I do git, let's do another change here. So if I do M3, and then if I do git that, and then I do, what did I do? This, M3. So that's, and I do git log again. You can see that I have 3 commits now. But again, all the commits that I had in my feature branch are not in my master branch. And this is what merge again is used for. If I want to put all of the commits, like merge 2 branches together and have all of the code that was in this feature branch in my master branch, I need to use git merge command. So, and again, I do this from master and I merge feature, right? So essentially what this means, so I'm on master, right? And I do git merge, and then feature, the branch I want to merge in, and then Vim editor is opened. So it's a little bit confusing how to use it. So to use it, you just press I key to enter and insert mode, so to modify the file. And then you can say branch, merge branch feature. So yeah, and we can feature, and then I don't know, this will add all, or like, I don't know, all code from feature branch. Okay. Okay, I don't know. Essentially, I'm just showing you that you can modify this commit. I'm actually good with the message that was there before, so it's pretty descriptive. So to exit the Vim editor, you just press colon. I know you press escape, sorry, to escape the insert mode. Then you do colon, W for write, and then you do, so if you can see here, do colon W, and then I do Q. So, and I just hit enter, and then if I zoom out a little bit, sorry. So now if I do git log, I can see I'm again on my master branch, and now you can see that in this history, if I actually expand the whole thing, I can see that my master now has everything, right, that the feature branch has as well. So here we can just scroll through history. So I have my M1, M2, F1, F2. Then so this is where feature branch stopped. Okay, just a second. Let's just clear because it looks a little bit confusing. So if I do this again, so this is all my history. M1, M2, these were done on master, right? Then I switched to feature. I did these commits. Then I switched to master and did another commit. And then I merged the two branches, right? And now remember, now you should see the order. So M1, M2, F1, F2, M3, and then merge commit. So, and now if I go back to the slides, so this is essentially how merge works. So we see M1, M2, F1, F2, M3, and merge commit. So these inserted like sequentially, right? So this commit was put after M1 because F1 and F2 were done after M2 and before M3, right? So that's the reason why they're in this spot. So, and then we have merge commit. So this is about merge. Now I would like to talk about rebase. So again, it was kind of a recap of what we did last time because we discussed merge, but not maybe not in such detail. So rebase, that's another concept. So rebase is essentially used for, where is it? Okay, yeah. So rebase is used, like it's really descriptive name. It just like to change the base of your branch, right? So imagine, so feature. So what I mean by a base, feature, the base of feature branch is M2 commit, right? So why is it M2? Because I branched off at M2 commit, right? So I created a new branch at this commit, and then I went to feature and did these two commits. So, and the base of this branch, of feature branch, is M2, right? So, and what if I want to change the base of the branch? So to do this, you just need to use rebase command, sorry. And essentially that's about rebase. So essentially rebase changes the base of your branch. And the like possible scenario where you might want to do that is imagine like, so you're working on a project. So you made a couple of commits, and then you branched off. And then, for instance, you discovered that this master branch has a bug, right? So a problem. And then you did this M3 commit to fix that problem, right, in that branch. But again, since this branch is based on M2, this commit is not included in this branch, right? So, and you would need to do this rebase to bring in the change, like for instance, bug fix or something. So you, again, it might be a little bit confusing, like what I just said, but essentially just understand that rebase, it changes the base of your branch. So that's about it. Let's probably do a small demo. Again, Okay, cool. Oh no, I just realized that I should have made a copy of the project before I merged. But anyways, let's it's already 6:40, so probably I will just go over the slides because I have other concepts to cover. And essentially, yeah, I don't want to confuse you too much. Essentially, Git rebase, what it does, changes the base of the branch, and that's about it. And now, and also I want you to pay attention. So if you rebase from feature branch, so right, you need to be on the branch you want to change the base of, right? So in this case, I want to change the base of feature. So that's the reason why I need to be on feature. And then I just do git rebase master. And then you just do, and this is what will happen, right? So it will just make the last commit in master branch the base of your feature branch. Okay. Okay, so there is a question. Does rebase merge as well, or would you do rebase then merge? So again, yeah, that's the difference I will explain right now. So merge, you actually don't need to rebase to merge, right? So in this case, I didn't rebase, right? So I can just merge, and this is what the outcome will be. So to merge, you just do git merge, and then the branch you want to merge. And then rebase, it's again, it's not necessarily for merging. It's like, imagine you have some changes made in master branch that you want to be reflected in feature branch. So this commit, in this circumstance, M3 will not be in feature. So, and okay, sorry, it was confusing, I know. Andrew, would you be able to help me? Where I don't know, maybe just add something if you're here.
Well, yeah, like the major difference between the merge and the rebase is that merge rewrites your history versus rebase just puts your feature branch on top of your master branch. So as Alexander explained with a rebase, if you started working on your feature branch from, for example, like you can see here from the commit M2, and maybe there was some work done on master branch that you are not caught up with. So for example, commit M3, and there could be more commits, right? So now your feature branch is outdated. It doesn't have some work that was done on the master branch. And to catch up with master, we need to do a rebase. We need to consider all of those M3 and M4, M5s and move them to our feature branch. Now, after you do your rebase, you could merge your feature branch into master. And actually the merging process will be very easy because you're basically putting two commits on top of your master branch. You're only bringing new functionality versus if you show the merge slide. Could you please switch to the merge slide?
Yeah, to the merge again. Yeah.
In this scenario, you can see that the commits are inserted somewhere in the middle of the master branch. And then I'll probably Alexander will explain merge complex later on, but you're basically overriding your master branch because it's not as easy to put some functionality in the middle of your branch, like it's happening with rebase. Yeah, I'm sorry if I made this even more confusing, but those two strategies are used to basically sync up with the rebase. It's like sync up your feature branch with master branch, and then bring in new functionality into your master branch with merging. And you can pick one over the other. You can use them both. You just need to understand what is happening with your branching system when you do them.
Yeah, thank you for adding some notes. I appreciate it for helping me answer the question. Yeah, and also So Josh, will explain this rebase further a little bit. So imagine, so after you do this rebase in this scenario, right? So you rebase the base of feature branch to be the last commit on master. And then, so after this is done, we can do rebase from master. So essentially we go to our master branch and we rebase feature. So, and essentially what this will do, it will behave similarly to merge, but but the sequence of commits will be like this, right? So instead of comparing to merge, it will be this sequence, and you also have a merge commit. If you do it this way, so firstly, you just change the feature branch base, and then the second step would be rebase feature from master. This is what you will end up with, right? So it's kind of also a merge, but it's not very good way of doing that. So as Andrew said, so first drawback of, so essentially like rebase, it's, I just explained this concept. So again, don't be overwhelmed. You're always welcome. Like I give you just a general overview of the concepts, so you kind of understand what is what in general picture, right? General outline, but you will be able to read about it more in detail in Git documentation. So there is also like official Git website that explains rebase more in detail. But generally speaking, rebase is problematic. I have done it only a couple of times during like my co-op. So, and essentially it's a bit dangerous. So the first drawback of doing that is, firstly, you lose the sequence, the original sequence of commits, right? So now the history is a little bit messed up, right? So you can see, so this is the right sequence, right, of commits. So if you do merge like has a clear commit history. So now you can see what commit was done, which commit was done after which commit, right? But in this case, you kind of a little bit, yeah, this master branch becomes messy if you do it this way. So this is drawback number one. So it kind of reduces the general understanding of the sequence. The second one, it also can have different like conflicts in your code, right? So which also can be problematic. Andrea, I would also appreciate your help. Do you know any drawbacks of rebase besides these ones that I just mentioned?
Not really. I mean, both systems have their drawbacks and they have their like pros and cons, right? Like different, you'll have, if you join real world projects, you'll probably have a system put in place if your team is doing a merging strategy or rebasing strategy. For example, I worked on a project that used rebases all the time. That's how we used to work. We would create a new feature, then rebase the master branch, rebase our branch on top of master to make it in sync, and then merge it into master. That's the way I worked with it. But
I see. Yeah, like generally speaking, when I was preparing this workshop, I read a lot of like, I don't know, negative comments about rebase in general. Like I didn't understand like really why, but like it just can have some unexpected unexpected consequences that might affect your project. So you should be careful. So maybe, yes, use rebase only if you want to rebase, like change the base of the branch, like what Andrew just said, to sync your feature branch or something or another branch up, right? But don't use rebase only for merging purposes. For like, at least this is what I read. So better to use just merge for merging, right? So for combining two branches, you can read about the like why in here, like Git rebase docs. So if you just type this, So yeah, it actually, you can see that this is like all the docs about Rebase. You can see how much Git has, and also incompatible options. So behavioral differences. So you can read about this here. So merge strategies. So I just explained one approach, how you can simulate merge with Rebase, right? And then recovering it from upstream Rebase. So this is like some problems that might occur. Yeah, essentially just be careful. Refer to this. So this is like the official website of Git. You can also read like all the docs are there. So everything what I'm talking about right now, you can find here and read more about it, more in detail. So merge, for instance, again, here, everything is explained, different flags, different options. Right now, I'm just covering the basics, the overview, okay? So that's about Rebase. Cool. Now, so if you do another thing about Rebase, so if you do just git rebase master, so essentially so the base of feature branch will become the last commit of master, right? But what in my scenario, what if I don't want my feature branch base to become the last commit of master? I want to be, so if I do just, let me just explain. So here, if I do git rebase master from feature, so if I do this command from feature, this will actually, from this scenario, it will put the base, so F1 will be not here, but it will be here, right? So it will put the base of feature to the last commit, right? To the last commit of master. But if I want like to pick a specific commit, so to pick a specific branch, so for instance, M3 in this case, you just do git rebase and then commit hash. Commit hash is actually like if you do git log, each commit has an associated commit hash with it. So it's like a global unique identifier of like ID of each commit, right? So you see it's like crazy. And yeah, it's long and it's unique, like to every single commit. So, and that's essentially, you can also like pick a specific, essentially what I'm saying here, you can just pick the specific base of a branch if you would like to. Sorry if that was confusing, probably it was very confusing, especially this slide. Now we will switch to a little bit different topic. Just a small conclusion, use Rebase to sync up the latest changes from a different branch, as Andrew said. And again, it's used to move the base of one branch. Yeah, just it's used to move the branch's base, and that's essentially it. Okay. Cherry pick. Cherry pick, it's essentially what it's used for. I will probably will not. So again, you can practice like simulate this scenario with commits, like what I did at the beginning of our session. You can just do different like commits, like simulate this scenario, and then you can practice it like after the session finishes, and just have only like we have limited time, so that's the reason why I will not be able to do demo right now. But so here, essentially, what cherry pick is. So cherry pick is used to bring in changes from specific commits, right, from a different branch. So essentially what that means, okay, let me open here. So imagine like this commit has like something new implemented, or again, a bug fixed, or something like, I don't know, like imagine you just want to duplicate this commit in this branch as well, right? So you want to cherry pick it, you want to carry it over, right? So to do this, you just you just do git cherry pick, and then you do commit hashes. So again, you can cherry pick multiple commits. So again, you pick a specific commit hash that you want, like you pick a specific commit that you want to carry over. In this case, like let's imagine this one, and then you would do git cherry pick on feature branch. Again, it should be on feature branch. Git cherry pick, and then you put commit hash here. Okay. So, and what this will do, the result will be the following. So it will duplicate this commit here, and it will make a copy essentially of this commit, right, in feature branch. So if I do this color, and then if I just dash a line here, so this is a result. This is the result of this commit, or this command, right? So essentially, cherry pick, just bring in changes from specific commits. So bring in specific commits you would like to. You can specify it like multiple commit hashes. So imagine like hash 1, and you separate them by spaces. So hash 2, etc., etc. So that's essentially how it works. So hopefully this this one is kind of clear. Then about squashing. So squashing is used to condense multiple commits, right, into one. Actually, let's maybe do let's do a demo here then for our squashing. So if I imagine, like, let me just give you a general overview, and then we will do a demo. So squashing is used again to condense multiple commits into one. Imagine you have like many commits, and you think, oh, maybe it's not like you want to squash them. So essentially, you will make these 3 commits as one, right? So you will put them together, squash them, right? In other words. And to do that, we just use git rebase, and then you use iflag, which stands for interactive, and then you just commit selection. We will do that in a minute, so don't worry. A use case would be like refactoring. So imagine like you do a lot of refactoring, and you have like a bunch of commits with the same message, right? So you have like imagine M1, M2, and then you have refactoring, 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 right? So you don't want to have like 3 commits with the same message, because like essentially they have the same sense in all of them. So you can use the squash to just, instead of having 3 commits that with refactoring, you will have just 1 commit with refactoring, right? So let me just switch to a project. Actually, I can use even this one, or I don't know. Let's create a new one just to practice a little bit. So again, I do the same. So project, do the same thing. So it's here. Again, get init. Oh, sorry, typo. Then touch. Index HTML to create a file, and then we do let's so again open Visual Studio Code. Cool. So if I go here, and then let's just do so M1. You can do git add, git commit M, and then I just do M1. Cool. Let's do the second commit, so M2. And now let's do like refactoring. Imagine like we wrote a bunch of code and now we want to refactor, right? So refactoring is essentially like improving your code, like changing, yeah, just do some minor modifications to your code. So let's imagine we have refactoring. So here, and then I can do again, git add, and then imagine I will just do refactoring. Then let's imagine I did another refactoring, and then we'll do git add again. Refactoring, and then git add again. Cool. So we now, if I clear this and I do git log, now we can see that I have, so this is my commit history, right? I have M1, M2, and then I have 3 commits of refactoring, right? So I want to squash these commits because we see that essentially they have the same kind of message in them. They have the same kind of purpose. So I don't want to have 3 commits with refactoring. I just want to squash them. So to do this, we use, again, git rebase command. So essentially, like behind the scenes, squashing is also kind of a type of rebasing, but I will not go too deep into this. You, again, refer to official documentation. So I do git rebase, and then I do iflag for interactive. So, and then I do commit selection. So imagine I want 3 last commits, right? So to do this, I need to select these 3 commits somehow, right? How do I denote it? How do I say that I want these 3 commits to be squashed? It's simple. So one thing you need to understand for this is what head is. So head is essentially like a place and a branch where their most recent commit was made, right? I believe so. If I'm wrong, please correct me. So in this case, at least it's denoted. Like if you do git log, you will always be able to see where your head is located. So the head is here. So I want 3 commits, right, including head. So 1, 2, 3, right? So, and essentially I do so from head and then 2 commits behind. So 1 and 2. So to denote this, I just do head, and then I use this thing, I believe, and then you just specify the number. So 2. So what this will do, it will pick head commit, and then also head of the branch, and then 2 commits that are behind head, right? So head and also 2 other commits. If I hit enter, it will actually probably 2 commits rebase. Okay, now I'm a little bit confused myself, but probably let me just escape somehow. Okay, now again it opens Vim, right? So Vim editor. You press I to enter insert mode, and then you will be able to type. And then, oh, actually, I got confused. Actually, it picked only 2 most recent commits. I thought it would pick like head and 2 other commits, but no, it just picked 2. You see here. So yeah, that was my fault. So if I just do pick, and then you just need to specify what commits you want to squash. So you do pick. So you need to leave 1 commit as pick, and then the commits you want to squash, you just need to change pick into squash, and then you press escape, colon WQ, hit enter, and now it it opens another window, and what this does is you see, this is a combination of 2 commits. This is the first commit message. This is the second commit message. And it just gives me an option to choose what message I want to display, right? So I want to hash. So this hash, it means just a comment. And So we want to comment this out. So, okay, I need to insert I again. So I want to comment out this part. Where sorry. So we'll just comment out this part. And then I just press colon. Oh, I press escape. So I left, or maybe actually let's do some other. So all refactorings. Okay, so I want to change the message here. So this is the message that will be displayed under the squashed commit, right? So now I press escape, colon, WQ. And then if I do git log, you can see that I have all refactorings and then refactoring here left. So essentially I squashed two most recent commits, right? So I picked them using head. So from head, I picked two most recent, and then I just squashed them together. So now instead of these two, I have only this one. Okay, so hopefully that makes sense. Cool. So any comments, any questions so far about Andrew? Do you have maybe any also additions? Maybe I missed something.
I'm good.
Okay, silence. So silence means either very confused or no questions. So again, cool. One, all good. That's thank you, Josh. I appreciate your confirmation. Yeah. So let's probably switch to our last topic. So this will be fork and clone. Cool. Oof. So if I go back to this slide for a second, just to have this diagram here, we have again local repos and remote repos. So remote repos, so these are remote repos, right? All of these are remotes. The remote repos, you can clone them, right? So you can clone remote repo into your local workspace, right? So into your machine. That's essentially what this says. Maybe let's actually do, yeah, so I will just explain. So what clone? So we did clone during our last session, intro to Git on GitHub. So here, again, clone, what this means, imagine I'm like search, I'm on GitHub and I just see, oh, this, I don't know, let's say Node Workshop is great. So I like this code and I want to have a similar, I want to clone this project on my local machine, right? So to do this, it's very simple. Essentially, you would just go, just clone, you see here under code, you go on a repo you want to clone. On GitHub, you copy this link that is given under HTTPS. And then you can go into, so let me clear something. Cool. So, and imagine I want to go, so I want to clone this project into this folder. So Git on GitHub. And to do this, it's very simple. I just do git clone, and then I paste the link I copied. That wasn't copied. Where is it? So if I copy it, hopefully now it's okay. Sorry. I paste it. Cool. So git clone. Okay, now it it has this window for me opened. You might also receive it. So just sign in with your browser or personal access token. I would use my browser option. Okay, receiving objects, cool. So I hope that it worked. So if I do ls, now you can see that I actually have this node workshop copied. So what essentially this means, I copied this repository into my local environment, right? So now you can see I have all of this code in here. So now I can see, okay, it complains that I can never open it. So now you can see that I have all the files here that are, so I have exactly the same files are as in this repo, right? So this is cloning. So essentially just like clone remote repository into your local machine, right? So you just use clone, and then you can do edits on your local computer. You do some commits, and then you can do push request. You can just do push for this to this repo, okay? And then if your changes are approved by the owner of the repo, you can also, I believe so. Yeah, if the changes, you can just push the changes. So, and these changes that you made on your local machine will be reflected on the remote repository, okay? So now it's a little bit different scenario with fork. So again, imagine we have, so I will demonstrate it to you with a bit different things. So imagine, so here I just logged in under DSC Conestoga GitHub. So let me just open it. Okay, cool. So I used 2 different accounts just to demonstrate you how fork works. Cool. So let's maybe like create a project in here. So imagine I want to just I create a project, my project. Again, it's not necessary for you to just to follow here. You can just watch and just try to understand the concept here. So I just create, I will add README file, I create a repository. So this is my repo with very simple README file, right? So that's essentially it. And now I can, so I will copy this link. And now under my other account, I will go under this link. So I go on this URL, and here, here you should be able to see. Where is it? Am I gonna? Oh, okay, it's on top. Okay, I was a little bit. Yeah. Here you will be able to see fork. So again, I created this project under my other account, just for demonstration purposes again. So okay, there is a project and I want to fork it. So what essentially it means, so under my other account, I go to this project, to this repo, and here you will be able to see fork. So I click fork, and what fork does, fork creates a copy of that repo under your account, right? So on remote repository. So essentially if clone, it creates a copy on your local environment, right, of the project, but fork, it creates a copy on your remote repo, right, on your GitHub essentially. So I do this fork, and then I just, where should we fork? So I just choose this. And then it's forking. So essentially it's creating a project under this GDSC Conestoga account, right? I created this. So again, I created this project under DSC Conestoga, and now I went to my GDSC Conestoga account, and I created and I did a fork of that repo that I created before, right? So, and essentially what it means, I copied the project from DSC Conestoga into GDSC, but I did it not locally, not like cloning, but forking. So essentially I did a remote copy, okay? So that's essentially it. And now imagine I want to do some changes. So I do like hello world 1. So I do 1 commit on my, again, I'm under my GDSC Conestoga. So this is not the original source of that repo, right? So, and then I want to add another file. So I create a new file like index.html. And I just do hello world. And then I just do commit. So now you can see that I have these. So I have index.html and I have hello world. So I have these changes only on the copy under GDSC Conestoga, right? But if I go to the original source of that repo and I refresh it, I still have the old version, right? So if I want, so imagine a scenario. You have like an open source project, for instance, I don't know, like you have somebody like creates a game and it's open source and you want to contribute to it, right? So to do this, you can create a fork, right? You create a fork, and then under your account, you will have the same exact copy, remote copy of the repo you just forked, right? So, and then you can do your changes in that remote repo like I just did. And then you think that this feature will be very useful to the original project, like to that community, where to that project in general, which you forked, right? And you want to carry these changes to the original project. So to do this, you will need to use pull request. So you can see here, so here you just, again, fork from remote repo, it creates a remote copy under your account. And then if you do some changes, you think the changes are good for like the central repository that you copied from, that you forked from, you can do pull request, right? And to do pull request, you just go to pull request and I do new pull request. And now you can see that it shows me like GitHub shows me different changes that I made. So it says I did 3 different changes to README file, and I did 1 change to index.html. And now you can see that I do pull request to the original repo where I forked from, right? So I do DSC Conestoga, my project main, and I pull from GDSC Conestoga, my project. So my repository, my remote, right? So now I create pull request, and then I just do great additions to the open, to your open source project, right? So I create pull request. Now this pull request gets processed. So this branch has no conflict. So it means that it's all good. So now if I go under the original repo, right? And I refresh the page. Now you can see that under pull request, I have 1, and somebody I now see that somebody did this pull request, right? So I can check this one. And I can go here and just see what changes were made to what files, right? And if I like this change, I can merge pull request. And then I confirm merge. And now all the changes are pulled in this project as well. Okay, so how did you find my explanation about forks? Like anything I need to clarify on that part? So you're welcome to unmute your mic if you would like to. So essentially, again, just to recap, fork is essentially kind of similar to clone, but clone, it copies remote to your local machine. So it copies remote repository to your local machine, remote project to your local environment. Fork, what fork does, it essentially copies one remote repo to another remote repo, right? And then you can do pull request to ask the owner of the original repository to make changes, right? To accept your changes. So imagine, like, again, a good example of fork would be like, I have like I create a game, like imagine like something like snake game or something. And Andrew did a fork of my repo, and he like made some changes. He added like a new level, and now, so he did all of these changes on his repository. And now he does a pull request to my original repository. And I'm, as the owner of this original repository, can accept or deny his pull request, right? So if I like his changes, if I say, oh, that's a great feature, then I can accept this pull request, what we just did, right? With this, under this account. If, again, if no, that you can just ignore, right? Or reject. So that's essentially about it. About fork. So great. So Josh wrote, it makes sense. So there is a question. Does this pull and fork relate to the identity of users? For example, if the users are collaborators, will they need to send pull requests? So yeah, correct. So collaborators actually do pull requests, right? So the owner of the of this central repository. So again, if it's my game and Andrew did a fork of my game, and he made a local like a change under his repository, and now he, as a contributor, yes, he will need to do the pull request, and I will need to improve this pull request, right? To make the changes that Andrew made, like to carry over the changes that Andrew made to my repository, to the original repo, right? So that's about it. Does Ariel, does this answer your question or no? Kind of. Andrew, could you collaborate, please? Sorry, help me a little bit to answer this question.
Well, I don't know if I understand the question correctly, but I mean, so I'm gonna explain like a real world scenario. You have a project you're working on with 4 other people. Probably most of the time, all of the people have access to the repository. So personally, I've rarely done forks, probably just for open source repos that I don't have access to. But let's just say that there's like 4 of you, and you're just like committing to the same repository. So in order to not to work on the same branch, because if you would be working on the same branch, all 4 of you, you would have conflicts all over the place. Somebody's doing one commit, then you're doing a commit that like overrides that one, and it just doesn't make sense to work on one branch. So usually you just separate work on different branches, and different people work on different branches, and then they create pull requests to say, hey, here's a piece of code that I've written on this branch, and I want to merge it into the main code that will be executed like in production. And then the other 3 people look at that code and say, okay, that feature is good. Let's merge that into master. Or they say, this needs some more work. Please fix this and that, and then we'll review it again. That's how usually development works in like projects with relatively small teams. I hope that's what the question was about.
They have access to my repo.
They probably just need to commit to my repo instead of sending requests. Yes, they can, but if once again, you're not going to give access to your repo to people you don't trust.
Yeah.
Usually you give access to people that you develop the app with, and you agree on a system that you're going to put in place. And you'll say like, okay, guys, let's just like agree on the system of branching and create pull requests. Or you can say, I'll trust you, and you can commit to master if you want, but like make sure you're all synced up and we're good to go here. On larger projects, if you want to, like, for example, I don't know, contribute to, I'm liking like an open for Twitch, for example, it's a great example of an open source repository. If you would like to contribute to Twitch's code, you'll need to create your fork of your own, because I mean, you won't be allowed to even like push any commits there, right? You'll need to create a fork and then push some commits there and create a pull request to the main repo. And then people from the Twitch's side will need to accept or deny a pull request.
So yeah, just to recap, I will reread your question and answer one by one. So does this pull and fork relate to the identity of the users? Essentially, yes. So for example, if the users or collaborators will they need to send pull requests. Again, as Andrew just said, if you trust people, you can give them access to your repo and then they will not need to. But again, like with the Twitch example, if you want to contribute open source contribution, right, to a huge project, to, I don't know what, like to Twitch, okay, then they, again, you are not given the access, right, to Twitch repo. So you will need to send pull request. And then if Twitch approves your changes, then they will be essentially brought into their repo, right? If they reject it, then no. So essentially, yeah, that's about it. Cool. Perfect. Yeah, thank you for your question. I appreciate it. Yeah, let's just do a small recap. We have 5 minutes left. So Git Ignore. Again, this session, this workshop was just dedicated to give you a general understanding of the concepts. Not necessarily like, I understand that you will not be able probably right now just jump right away and like do everything what I just described to you today. But yeah, again, the more you practice, the better you become. So yeah, practice is important. Check this documentation, right? So read Git docs. So this is the link. So if you're interested, again, these are just like the most common concepts. Obviously, that's not everything. It's like the important ones. Besides the ones I covered in the first session. So again, let's just do a small recap. So Git Ignore is used, the Git Ignore file is just used to hide your secret files, your passwords, your API keys. Again, the data you don't want to expose to the outside world. Merge versus rebase. So we kind of talked about it. So merge is essentially used to merge two different branches together, right? So all the changes are reflected in one branch. And then rebase, it just changes the base of a branch. Then cherry picking, it just like if you want to carry over a specific command, a specific commit from one branch to another, you would use cherry pick, and then you just need commit hashes. Again, commit hashes are just unique identifiers of every single commit that you do under Git. So if I do git log again, okay, not here, but I showed it to you earlier, right? So this is so again, git hash is a unique identifier of each commit. So you need to, yeah. So and you would need these hashes to do cherry picking. Then another concept we covered was squashing. So essentially condensing multiple commits into one. So imagine instead of these three, you want just to have these. So you want to merge, you want to squash three into one, right? Like in case with refactoring, right? And the last thing we talked about was fork and clone. So again, clone, just clone to your local repo, and essentially, and fork is used most of the times for open source contributions, right? So, and it's essentially it's used to protect to protect your repo, right? So you will need to ask permission. People would need to ask permission if they want to contribute to your project, right? With pull requests, right? So that's essentially about it. Some notes help us spread the word about the club. Hopefully just, thank you for your time. I do appreciate you coming. Hopefully you learned something new. Again, I do suggest you learn. Again, we have a bunch of different resources, YouTube, Git documentation, right? So try to learn as you go. So obviously, I believe you will be exposed to Git a lot when you are in a professional environment, right? Because Git is essential. Git is very important because it's used on a daily basis, essentially. That's about it. So here are the links again to our social media. Just subscribe. We will post this session to our YouTube channel. So if you want to rewatch or share it with your friends, you're welcome to. And that's essentially it. So I appreciate also all of the active participants in the chat. So that's very valuable. Feel free to ask questions.